In this video, I will try to explain what is the necessary and sufficient condition for a compound to show optical activity and which substances are optically active and which substances are not. Okay, so let's start our discussion. Only those substances whose molecular configuration is not superimposable on its mirror image are optically active, and the compound whose molecular configuration is superimposable on its mirror image is optically inactive. In fact, this is the necessary and sufficient condition for a compounds to show optical activity. Okay, now we will clearly know it through some example. Okay, in case of cis-2-butane, okay, obviously superimposable by simply translation to the left, thus cis-2-butane is optically inactive. Okay, in the case of propanoic acid, okay, its mirror image is superimposable by turning upside down along the axis passing through CH bond. Thus, propanoic acid is optically inactive. Okay. In case of lactic acid, obviously non-superimposable, thus lactic acid with the molecular configuration A is optical active. Okay. In case of trans 1,2 dimethyl cyclopropane, obviously non-superimposable, thus trans 1,2 dimethyl cyclopropane with the molecular configuration X is optical active. Now we have noted that only those substances whose molecular configuration is not superimposable on its mirror image is optically active. Then under such circumstance, logically we are forced to say that the compound with the mirror image molecular configuration of the above substances is optically active. Thus, lactic acid with the molecular configuration B is optical active, and trans 1,2 dimethyl with the molecular configuration Y is optically active.